Hello, I am Pete Demar with Battery Research and Testing, and I will be narrating this session of our stationary battery maintenance tech tips. This is tech tip number 2, preventing thermal runaway in vented batteries, lead acid or nickel cadmium. In this tech tip, we're going to explain how easy it is to detect and thereby prevent a thermal runaway in a vented battery. These are also called flooded or wet cells. I will just call them vented cells in this tech tip. But before we go further, first some COA statements. 1. If you do not know how to safely work on stationary batteries in either energized or off-charge battery systems, do not attempt this. If you do not know what the proper PPE is and use it, do not attempt this. Okay, now that we've covered that, let's get back to this session. First, there never has been, nor will there ever be, a thermal runaway in any lead acid or nickel cadmium battery that does not first provide you with months or years of advance warning. You just have to be paying attention. The pictures that are scrolling are just some examples of different thermal runaways in vented cells. This can occur with anyone's cells, so do not think that any particular manufacturer, anyone that has any involvement with stationary batteries, is familiar with thermal runaway with valve-regulated lead-acid ones, but you may not be as familiar with it in the vented ones of either the lead-acid or the nickel designs. I personally am familiar with at least 5 that occurred just over the past couple of years. With one NiCad thermal runaway, we were called to come help, and when we arrived on site, 3 hours after the battery had been disconnected from the site, the jar temperatures were still about 200 degrees F. A problem that we observe with a number of applications is when the equipment manufacturer, in attempting to take up as little space as possible, they install a battery cabinet and the cells are on trays with the cells all banded together. There is no space between the cells to allow airflow between them, which helps to transfer heat from inside of the cells to the air around them. While this does save floor space, it must increase the risk to the cells. Even though there is a difference in the causes of the thermal runaway between the vented and the VRLA designs, the early warning signs are identical. So it is easy to detect a pending thermal runaway when it is still in thermal walkaway. As we all know, thermal walkaway is when the battery is just beginning to tell you that there is a problem coming. If you do not take action, of course. The only difference that we are aware of when the warning signs between VRLA and vented batteries is that with most vented cells, you can see the electrolyte levels dropping. If you are having to add water more than once a year under normal conditions, then you have a problem. While recombiners do help to reduce the labor required to maintain the electrolyte levels in vented cells, they will not reduce the risk of a thermal event. This is different from the VRLA ones. Okay, let's get to how to catch this early on. There are only 4 measurements that need to be taken on a battery string to know if the battery is in thermal walkaway or real close to a thermal runaway. Those 4 measurements are as follows. First, the overall battery voltage on float. Second, the current flowing through the battery. Third, the ambient temperature. And fourth, last but not least, the temperature of the battery. The reason for each of those readings and their importance is as follows. First, the overall voltage reading divided by the number of cells tells you if you are floating the battery within the correct range as recommended by the manufacturer. This reading is impacted by the temperature of the battery. Second, the float current is critical because there are known acceptable and unacceptable current requirements for every battery size and type manufactured. Each manufacturer can provide you with their specific values or ranges dependent upon the model. You also can use the IEEE 1635/ASHRAE21 battery Gaussian calculator to determine approximately how much float current your particular battery model should require during normal charging. Anyone that has anything to do with stationary batteries should have a copy of that document, as it is so informative on multiple levels. Third, the ambient temperature is important because if the battery temperature is warmer than the ambient temperature and an air conditioner is not abnormally cooling the room, then you have a problem. Fourth, the temperature of the battery is critically important because if it is more than 2 or 3 degrees above your normal ambient or the equipment around it, you are heading towards a thermal event. Very, very important. When you have a current flow that's going through the battery that is greater than it's supposed to be, and the battery is not in a recharge or an equalize, and you are at an acceptable room temperature, then the battery is telling you it has an internal issue. Could be shorts, could be many things. This increased charging current is creating excess gas generation, which lowers the electrolyte levels, plus it's heating the cells. The problem is easily observed by the cells in the battery being hotter than the area around it. When you have both an elevated float current and an elevated cell temperature, you do have a problem. The only delaying actions that can possibly buy you some time if you were in thermal runaway is to lower the float voltage. This is done in order to lower the current flow through the cells. Obviously, it also helps if you can get fans blown across the cells, as this will help to remove some of the heat being generated. Usually, the only sure way to stop a thermal runaway in vented cells is to disconnect the battery from the charger. So that you do not get surprised with a thermal runaway in your vented battery, it is best if you trend your readings over time, those 4 readings, which is why we created an Excel spreadsheet that automatically takes those 4 readings and alerts to danger. All anyone has to do is to one time enter in the information for the battery string, the name, model, amp hour, number of cells. Then each time you enter in those 4 readings, it will alert you if you have a potential or a real thermal condition. If you'd like a copy of that free program, just contact us at info@batteryresearch.com and request one. It is a very simple program, but it works. You can also accomplish the same monitoring of those 4 items without having to go to the battery and manually take those readings if that is desired. You just need to install a monitor that is designed to monitor those same 4 parameters and which will alert you to any battery changes. Changes are important. Of importance is the need to accurately measure the current down to about 1/10 of an amp. One example of these is a BEM, that's a battery event monitor. The benefits of a BEM type monitoring service is explained in tech tip number 9. Hopefully, this tech tip has been of benefit to you. If you are interested in learning more about what we do or how we might be able to help you, please go to www.batteryresearch.com and look around. If you would like to be notified when we release a new tech tip, please go to info@batteryresearch.com and tell us to notify you when we release one. Or if you just have a question on a stationary battery subject. Just do the same. Oh, yes, if you have any experiences or pictures of unusual things that you have found, please share them with us so that all of us in this industry can benefit each other. Have a great day, stay safe, and stay healthy, and thank you.